Okay, this is all about really hardcore exponent stuff. So I got to practice with you exponentials where we have fractions that are exponents, and then we have fractions that are put to fraction powers. All right, so it gets pretty intense on that. So I need you to be with me 100%. Cell phones that were okay a minute ago, please take them off your desk, put them away so that you won't be tempted if text comes in to get your phone taken away. All right, you ready? So here's the first one. If I said 9 to the 1/2 power, somebody's going to remember what the easiest fraction exponent means. What does that mean? You're doing something to the 9. Do you remember? I mentioned it in class on Thursday, but I mentioned it real quick. I'll give you this hint. The answer is 3. What's that called? It's called the square root. So this means the square root of 9. And you already know the square root of 9. I hope you don't get this all confused. Some teachers have kind of hinted that there's a plus and a minus answer, but there's not. There's just 3. If you do it on a calculator and you graph it, you'll see there's not a line at 3 and -3. There's just one answer. Okay. The reason that we ever have that is for something like this, and that's when you square root and you get the absolute value of x. It never comes out 4 and -4. It comes out 4 and -4 after you have this absolute value. Okay. All right. So let's see if you can tweak it a little bit and still do it. That's not square root. What do you think that's called? It's not square root. Cube root is correct. So what is it? Is it like 2? Because 2 times 2 times 2 makes 27? 3, because 3 times 3 times 3 makes 27. So the answer is 3. Do you understand what just happened there? Okay. How about this one then? 100 to the 1/2 power. But then I want you to take that and times it by 3 and subtract 1. Oh, it's getting more intense. Really not that bad. I'm just trying to make you realize this can just be one little part of a big, complicated question. It's a good question. Is 100 to the 1/2 different than a parenthesis around it? 100 to the 1/2. You wouldn't need those parentheses right there because the answer would be the same. If there was a negative involved, then it would absolutely make the answer different. So, all right. So, what's the square root of 100? Times 3 is? Minus 1 is? 29. Okay. All right. How about this one? By the end of this hour, you'll be able to just snap that off and go, oh yeah, it's this, and then you do that to it, and so the answer is this. It'll just take you like 3 seconds. Here's my hint. I can do this in 2 parts. First, I can take 27 and put it to the 1/3, which we were just doing a second ago. And then I can put that to the second. Why? Because when you have powers to powers, don't you just multiply these? And 1/3 times 2, doesn't that come out to 2/3? So that's why I can break that up into 2 parts. So then it's really not that hard. What's the 27 to the 1/3? Hello, this is supposed to be easy. What's that part? 3, and then 3 squared makes 9. So the answer is 9. Okay, let's do another one like that. That's tricky. That's too tricky. I'm going to go the other way. Now this time, I don't expect an answer as like 26 or just a simple decimal. I want the answer as 4 to a fraction power. 4 to like the 4/5, or the 2/3 of the 3/2, or the 1/3, or the 1/3 times 2 kind of thing. I really wish it was as simple as 4 to the 3/2 because that's the order it's in and everything, but it's not. It's 4 to the 2/3. And one way I can show you that, or help you remember that, is that this sign, that's the sign of what root you have. The roots go on the bottom just like in plants. It's dumb, but it might be a way you can help remember it. I had trouble remembering which one was which until I started saying that, and then I got it right every time. The root goes on the bottom. All right, so then what's the answer? Well, I can't do the third root of 4 in my head. So I couldn't get the answer unless I used a calculator. We're not using calculators in tonight's homework. If we were, it'd be really easy. You just type in 4 to the power of 2/3, enter, and you wouldn't even know what it meant, but you could get a decimal answer. Okay, how about this one? And if I don't put what root that is, do you get it still a square root? Pausing. All right, did you get 4 to the, oh, I wish it was 2/5, but it's not, it's 5 over 2. Raise your hand if you had 5 over 2. That's right. Now, can you do it? I think you can. So here's my suggestion. You break this up into 4 to the 1/2 to the 5th. I want you to see the genius in that. 4 to the 1/2 you can do. And then 2 to the 5th you can do. And see how I broke it into 2 parts? Because that times that equals that, but yet it allowed me to do it in 2 parts. Now some of you might be saying, couldn't you have done 4 to the 5th to the 1/2? Yes, but that would have been dumb, because I'd have to do 4 to the 5th, which is this huge number, I don't even know what it is. And then I take the square root of that, and it would work. It'd give you the right answer. But it's just impossible. Always make it smaller first before you make it bigger. This makes it smaller first. So 4 to the 1/2 is 2, and then 2 to the 5th is 32. Go ahead. 32, raise your hand if you had a 32. All right, awesome. Then what's next? What's next is, what if they're negative fraction exponents? Holy smokes. So what if we have 27 to the negative 2/3? Hint, break it up into 3 things. 27 to the something, to the something, to the something, and then do it from the inside out. And first of all, make it smaller. And hopefully you remember what a negative exponent does. I'm going to do it off to the side. If I had 2/3 and I put it to the -1, it would make it into 3 over 2. It flips it. What if it's a normal number like 5 and I put it to the -1? It flips it. How can you flip a 5? Because a 5 is really a 5 over 1, right? So then, can I flip this thing and say it's 1/5? Yep. You can flip even whole numbers. Now, I'm saying flip, but what's the right word for that? Is it inverse or is it reciprocal? Be careful. Reciprocal. All right. There's different kinds of inverses. There's additive inverses and there's multiplicative inverses and stuff. Reciprocal's easier. Okay, so what do you think? How about 27 to the 1/3, so we can make it smaller before we make it bigger? And then squared, and then times -1. And these are all times because power to a power to a power multiplies all together, and that still gives you -2/3. See how that's cool? And then I can do it one step at a time. First of all, this is 3, and then I square it, makes it 9, and then it's -9. No, it's not. It's 9, and then what's that -1 do to the 9? 1/9. How many of you had that exact thing on your paper? All right, it's only half the class, so I got to try another one like it. Try this one. 8 to the -1/3 power. Don't say it. Figure it out. Pausing. Did you realize it was 8 to the 1/3 and then to the -1? Remember, you multiply things like that are up in the powers like that. That times that makes -1/3, so it works. And then this part's 2 2 to the negative 1. Please don't say it's negative 2. What is it? 2 to the negative 1. What is it? 1/2. Raise your hand if you had 1/2. Okay, awesome. Now, all of that's being done so that you can handle a problem like this. You're not ready for this yet. But by the end of the hour, you'll be like, oh, yeah, no big deal. You just replace the 8. And then it's easy. All right, I'm going to walk you up from the bottom to the top. And you'll need to know that whole fraction exponent thing in a minute. Okay, so here's a simple one. I know you can do this. Think about it. Think about it. What's x got to be? 5. Look, 2 to the 5th equals 2 to the 5th. See? It's 5. All right, so how could I do that? A lot of people want a thing you can do to both sides to like solve it. I totally get that. We have something that's called logs, but you don't learn that till the next chapter. You'll see why later, because logs also require you to be really good at fraction exponents. So, how do you solve this? You can think your way through it. If the bases are the same, then the exponents have to be equal. So let me give another one. 3 to the x plus 1 is equal to 3 to the 4th. This is not rocket science. What does x have to be? X has to be 3, because you just try to make them equal. What equal? The exponents. The bases are already equal. See what I mean? Okay, how about this one? 2 to the x plus 1 equals 4. Wouldn't it be nice if that 4 was a 2 to a power? But it can be. Couldn't you replace a 4 with a 2 squared? And then it will be a 2 to a power. Because 4 is 2 squared, right? So then what's the answer? What does x have to equal? 1. Because that way that equals that. So x equals 1. All right. Try this one. 4 to the x plus 1 is equal to 4 to the 6th. Don't say it. Solve it. Figure out the answer. They'll get harder. It's supposed to be the easy kind. Now, I wish I could say that mathematically that those 4's just canceled, but they don't. There's no way you can like divide both sides by 4 and make them cancel. That doesn't work. You can't just subtract the 4 from both sides and make them disappear that way. There's nothing you can do that makes them disappear. But you can say that that must equal that. X plus 1 must equal 6, and that's an equation that anybody can solve. X equals 5. Raise your hand if you had x equals 5. Okay, awesome. How about this then? 6, no, that's a terrible number. Bad choice. Hold on. 8 to the x is equal to 4 to the 2nd. All right, wouldn't it be nice if they both had the same base? Could I make the 8 into a 4 to a power? It seems like you could, but no. Because 4 to the 1 is 4. 4 to the 2 is 16. So I can't make them have the same base unless, wait a minute, yes I can. 8 could be 2 to the 3rd to the x. What just happened? I replaced an 8 with a 2 to the 3rd. Isn't a 2 to the 3rd the same as an 8? And then this 4, couldn't I replace that 4 with a 2 squared? And then this squared is right there. Aren't those equal to each other? So all I did is substitutions, and magically, I've got the same base here. Which means that must equal that. So 3x, this is times, right? 3 times x is equal to 2 times 2. So 3x equals 4. So x equals 4/3. I want you to ponder what just happened there. I replaced the 8 and the 4 with things powers so that the bases could be the same. That's the hardest kind today. So you got to be able to look at numbers and kind of know what can go into them, like this. This would be about the toughest, maybe not the toughest, but really close to the toughest question you could have on your test. Because a lot of people don't know that 64 is actually 4 to the something. Very good. 4, I'm going to write it off to the side. A little factoid that some people know and other people don't. 4 to the third is 64. Try to use that. See if you can do this. I know I'm leaving some of you in the dust here. If you're getting lost, I'm going to back down to an easier question, then get you to compare with the kid next to you and see if you can do this when it's slightly easier than this. Replace the 64 so that you have the same base on both sides. I'm replacing a 64 with what? 4 to the third. And then I still got to have that x plus 1 up there. I'm using parentheses a lot more than normal, so you should too. Now that these are the same, then this must equal all that. And I bet you a lot of you would have written 3x plus 1. Hopefully you won't make that mistake now that I've called it out. You won't say 3x plus 1, you'll say 3x plus 3. So 2x equals 3x plus 3. Notice me having to distribute that. And then I can subtract 2x from both sides. Then I can subtract 3 from both sides. And boom, there it is. Raise your hand if you had -3 before I got there. All right, I got most of the class on that one. Without help, other than checking with the kid next to you. Solve that for x. Hint, make the bases on each side the same. Pause, and then check with the kid next to you. Excellent, you're doing it right. We're going to leave this side alone, but instead of the 4, we're going to replace it with 2 squared, and then what? I like it. Yes, perfect. Now they have the same bases. Technically, we don't cancel the bases, but we set these equal, and then what did you get next? Raise your hand if you had x equals 1. Okay. And the last one, and this is where you're going to have to change both sides. Notice this one, we only had to change one of the two. What if both of them have to change? Make those bases the same. Hint, you can't make x into 4 to the something unless you do something really complicated. So maybe you should change both bases. I'm going to pause for a second and give this a try. Once you get that, it should be like, oh, I see. Because now I got the bases the same. That's equal to that. 4x equals 3x plus 9, not 3. It's got to distribute the 3. Take away the smaller x. 3x is smaller than 4x, so we take that away and we get x equals 9. Boom! Raise your hand if you had 9. Awesome. Okay. Then the only thing left to trip you up is what if they are fractions like this? Whoa. Hint. Try to replace the bigger one with something smaller and squared or cubed and put to maybe even a negative power to flip it. Then you'll have the same bases. Then you can cancel out. Well, you're not really canceling the bases. Then you can ignore the bases and set the powers equal. So replace 49/9 with something smaller so it matches the other side. All right, this is the real stretcher. And if you don't know, you should at least want to know. So, in a moment, see what the other kid changed that to. Not the final answer. Final answer is easy, actually. Once we rewrite that thing, it's going to be easy. But see what they rewrote 49/9 as. I'm going to pause while you try that. Okay. This side was fine because I could make the other side match. The other side, if I made it 3/7 and I squared it, it's close. But do you get how that would be 9 over 49? But I want 49 over 9. So who was smart enough to figure out that I had to put a negative in the power? Ooh, only one person caught it. No, 2, 3, 4, 5, 6, 7. Okay, fine. A bunch of people caught it. Yay. That's what I was hoping. So this equals that, and then I need the x plus 1 still. The key substitution, if you missed this, was that had to be replaced with that. Why? Because when you square it, you make 9/49. And then the negative makes it flip over. So now it's just 2x equals negative 2x plus 1. Oh, I just didn't distribute it there by accident, but I caught it. Negative 2. And then I'm going to subtract 2x from both sides. Whoa! Mind blown. Has that ever happened to you before on an equation? You did everything right and you like lost the variables? Oh, I screwed up something. Dang. I screwed up something. Negative 2x and negative 2x makes negative 4x. Boo. It's going to be a boring one. And then I'm going to subtract or add 2 to both sides. And then divide by negative 4. Final answer, negative 2/4, which I'm going to reduce to a half. That is as hard as anything you would have on a test. Like, that'd be the hardest question on the test, other than the R4. That's a toughie. But there's one like that on tonight's homework. Okay. I don't want to do more practice on that because I want to get you into the homework and like thoroughly well into the homework. Because it's like got 14 questions, but I can get like the first 4 or 5 of them done. And you'll only have 10 questions. And 10 questions is very reasonable for an honors high school math class. Okay, so I'm going to pause for a second while we pull that up. Okay, so here is our little homework quiz. I hope that you feel like that first problem is really easy. Yes, x is equal to... stop giving the wrong answers on purpose. It's 3. And then on number 2, hopefully that again becomes really easy because the bases are the same. So you just have to set 1 minus x equal to 4. And you can think of this in your head. 1 minus, oh, it has to be a negative number. Minus a negative what? Say it.
3.
Negative 3. All right. And number 3. 3 to the something equals 9. Ooh, there's a toughie. Now, you can just do it by thinking 3 squared is 9. Or you can do it by making the bases the same and saying 9 is really 3 squared. So then it's 3 to the x and 3 to the 2. So x equals 2. All right. This is the first one where you actually have to try. Look at number 4. Do you get that that 27 could be rewritten as a 3 to a power? 3 to the what? Come on, a little crowd participation goes a long ways. What's 27? 3 to the what? Third. Okay, and then that has to equal that, and that should be pretty easy. Okay, this 5 is the first one where you're not going to want to just replace the 16 with like an 8 to the something, because 8 to the something doesn't equal 16 very easily. You could do something really complicated with a fraction exponent, but other than that, I would just replace the 8 with a 2 to the something, and replace the 16 with a 2 to the something. And then you'll have the same base. Okay, we're up through number 5. You got about 10 left. Remember, the goal is to get the bases the same and set the exponents equal. And that's all I got for you for today.